This video, I'm going to go over the dilation drawings and just some kind of basic ideas about dilations that are very evident in this process of drawing these without a coordinate system. Dilations is all about multiplication. We have some scale factor k, and what we're doing is we're taking some original shape and we're multiplying by scale factor k. So I take the pre-image, which we should know is our original figure, and we multiply by the scale factor, and that's going to give us some portion of our image. Now this idea works with a lot of different parts of pre-image and image. So for example, if we were using the coordinate system, so coordinates, if I have some point, let's just call this point A. If this point is at 2, -3, and let's just say I have a scale factor of 3, all we do is I take each of these coordinates, multiply by that scale factor, and I get the new values. So we would say our rule for this dilation would be xy goes to 3x, 3y. So that point A, which is at 2, -3, would go to 2 times 3 is 6, -3 times 3 is -9. Okay, so that's where that point would end up after this dilation. This relationship also works with side lengths, right? So if I have a triangle, let me make that a little bit nicer here. So if I have a triangle and I dilate that triangle by a scale factor of 3, all right, if this length over here is 1, then its corresponding length is 3. If this length was 2, its corresponding length would be 6. Now, obviously, this isn't to scale, but I'm just imagining that these sides correspond, right? This is the dilated figure. So this is always the case. If you can kind of keep this in your mind, that we always take the pre-image times the scale factor to get the image. This idea works with quite a few different things, right? It works with coordinate systems, it works with side lengths, and that's the same idea that we use when we're doing dilation drawings as well. So this is just a little bit different. So when we do the dilation drawings, this is without a coordinate system. So I've got some point, and I've got some figure. I'm actually going to do this one as a reduction, just because the other examples we've been talking about have been enlargements. So I've got my triangle here, and if I want to dilate this with a scale factor of, let's just do k equals, I don't want to do 0.5 because I think that one's too easy. We've talked about that idea a lot. 3/4, let's do, I guess let's just do 2/3. So if we want to dilate with a scale factor of 2/3, a couple things we should kind of be thinking about right away. This is a number that's less than 1, so this is going to be a reduction. And I'm still going to be taking something to do with the pre-image and just multiplying by the scale factor. And in this case, it's this length. Since this is my center of dilation right here, right, this original point, this is going to be, I'm just going to call this point O. We've used that as our center of dilation. So O is the center of dilation. And this basically works exactly the same as it would if it was a coordinate system. We can take this distance to that point in our triangle, and now we're just going to take this distance times the scale factor and then plot those new coordinates. So already just kind of thinking about this before I do any sort of measuring or calculations, if this is going to be 2/3 of the size, what I'm kind of thinking right away is I'm going to take this distance and I'm going to cut it into thirds. So it's going to be something like this. And my new figure is going to be 2/3 of the original. So that would be 1/3, 2/3. So this original coordinate is going to end up somewhere in here. This one is going to end up somewhere in here. And this one is probably somewhere in here. This is just a ballpark. All right, so I should, before I even do any calculations, I should know that it's going to look something like this. Okay, 2/3 of the original size. So now what I can do is I would take a ruler and I would actually measure this. Okay, I'm going to choose some numbers that are going to work out kind of nicely. So let's just say that from here to here was a length of 9. Okay, that entire length, 2 point A was 9. So what I would do is I would take 9 times that scale factor of 2/3. And when you do that, you will get 6. So then I would go and I would measure from my center of dilation. I would measure up 6, and that's where that new coordinate would go. So again, I don't have a ruler on this device. I'm just kind of ballparking here. Okay, so this is where my new value of A would go. And I would do the same thing with all of the other coordinates. Okay, so say that this was, again, let me just pick a nice number. So say that this length is 12. Okay, from the center of dilation to point B was 12. So then I would take 12 times the scale factor. And when I take the 12 times 2/3, 12 times 2 is 24, divided by 3 is 8. Okay, so then I would go from the center of dilation, I would go 8 along this line, and this is where point B is going to end up. Okay, and again, it's going to be somewhere in this general vicinity. Point C would end up, again, somewhere in this vicinity here. And then when I make my new shape, it should look exactly the same. It's just going to be 2/3 of the size. So it's the same process whether we're enlarging a shape or reducing a shape. Always take the image, sorry, not the image, the pre-image, our original shape, times the scale factor will give us the new. Right, and that is the same for these distances as it would be with side lengths, as it would be with coordinates. And if you can remember that, that's really going to get you through a lot of the big ideas in dilations. And you can use that to find other missing pieces as well. If you just set up that equation of pre-image times the scale factor equals the image.